And here we go. So they want you to find the greatest common factor.
Yep.
I'm sorry, it says use the ladder method and find the greatest common factor of each number. So for 32, you're going to do the 2, the 16, the 2.
The greatest
8.
common factor for number 1 would be 8.
That is correct. Yes. Okay. How about for number 2?
7.
Yes, that is correct. And just snip that in. Okay. Let's keep going here. Number 3.
15.
It is 15. Good. How about for number 4?
6.
That's also correct. How about for 9? I'm sorry, for 5. I just gave you the answer.
That's as far as I got.
Okay. So you've not done 5, is that right?
I've not done 5, 6.
Okay, so
7.
you're doing them correctly because you're. I mean, as far as I can tell. So with that ladder method, you're going to get 3 squared here, and then you're going to end up getting. So I guess my question to you is, when you do the ladder method here, like I'm doing, how do you know? How are you deciding between, like, when you look at 3 squared and 3 squared times 2 squared? How do you?
What we do is we write them out like 3 times 3, and 3, 2 times 2 times 3 times 3, something sort of like that.
I see. Yeah, that's what I was going to suggest, is doing it at slightly differently. 2 times 2 times 3 times 3, and you sort of say, oh, there's 2 3s in both. Hopefully there's multiple 3s in the next one, and there are. So this is 3 times 3 times 3 times 3. So yeah, your GCF will be 9. Okay, let's do number 6 whenever you're ready. We got plenty of time, no need to rush here. Let me know when you get all this down and we can look at number 6 together.
Almost. I've got one more thing.
Sorry. Yeah. There is, I should comment that there are sort of some other ways to do this that are.
Well, this is the way that I think my instructor wants.
Yeah, when the instructor says you have to do it this way, you're pretty limited with how you can do it.
So it'd be 9.
Yes, the GCF is 9.
Okay.
All right, let's look at number 6. All right, so we'll just do the same thing here. Your prime factors. How far up in class did you go with prime numbers? Did you?
We went all the way up to like 87 or something.
Okay.
High up.
Yeah, that's great. 87 is not prime though, by the way.
Well, it was something really high.
Yeah, just be careful there.
Yeah.
All right, so let's do the ladder for each of these. You're welcome to look at the screen if you want. I'm going to work it out with you.
Okay.
How are you doing on this one?
I'm almost done. Okay, so, and then for the greatest common factor, I got 12.
Yes. Now, if you're seeing my screen, you're seeing that I circled them. I actually circled them like one at a time. I said, okay, there's that 2, 2, and 2. And then I was like, well, I wonder if there's another 2, 2, 2, and 2, and then 3, 3, and 3. That is one approach to doing this to make it faster. All right. So we got a number of problems on this third page to prime factorization using the ladder method.
Yeah,
Before we jump to that, I guess I want to ask you, because we didn't get through everything from from our lesson on
I got through it.
Monday. Okay, and does your teacher give you feedback right away, or does it, because I know that there's like an issue where if you don't get them all perfect, you have to redo it. Are there any that we need to redo yet, if you know?
Nope, I got them all right.
Nice,
Oh, I
well
got
done.
one, like, I just misplaced one number,
Okay,
but it was still all the right answers and stuff.
good, that's great. Yeah, so like once we know what the teacher wants, we just keep giving the teacher what they want when you're submitting homework.
Yeah,
Okay, so for 99 here, what is the first number to try?
I'd try
What is
3.
3? Yeah. Now, how are you doing the division? Like, are you coming over here to the right and doing it sort of long division way?
Well, what I've been doing for at least for these ones, if I get stuck though, yeah, I go over to the right and do the long division. But most of these I know pretty
Okay.
well.
Yeah, and that's why I'm asking, because it can get really tiresome to have to keep going off to the right and doing the long division. What do you do with 11?
11.
Yeah.
So what I do is that's a prime number.
Yes. Great.
So
Now here, are you writing it as 3 squared times 11, or are you writing it as 3 times 3 times
I'm
11?
writing it 3 squared.
Cool. That's correct.
And then yeah.
Okay, so let's keep going here. Number 10. I'll actually just number 10 here, it's 620. So you notice the larger the number gets, the more space you're going to need with your ladder.
Yeah.
Divisibility rule for 2 is if it ends in a 0, 2, 4, 6, 8. That could be helpful here. Did you talk about a divisibility rule for 3?
Maybe.
Okay, so I actually post divisibility rules on my website. I'm going to grab a link real quick for you. But the rule for 3 is you add the digits up. 1 plus 5 plus 5. So you add the digits up, and if that number is a multiple of 3, then you know it is divisible by 3. So let me grab that link. I'll drop it in the chat.
Yeah, I think we went over that in.
Okay, so this one is not divisible by 3. So what is the next prime number after 3?
5. And that's sort of what my instructor said is if it ends in a 5, just use the 5. Just go to 5.
But that's not always true. That's
Yeah, that's
that's
what my instructor said as general rule.
yeah, it's not correct. Like at 15, you would start with 3
My
rather
instructor
than
said that it could be either or. It doesn't really matter.
okay. Um, it's rare when I want to disagree that strongly, but the order really is matter. It does matter here. You want to do them in that prime order that's given. So move in that progression. The divisible rule for 3 isn't that difficult anyway. Just add up to a multiple of 3. 5 is ending in 0 or 5. So this one you may need to come off to the right and do, you may not, but if you ever counted nickels to make $1, there are 20 nickels in $1. And the analogy is that there's 20 fives in 100. Sometimes that helps to figure that division out quickly. How about 31? What number goes into 31?
Um, Probably would that be prime?
It is prime, yeah. Now, the way you would do it is you would start testing new prime numbers like 7, 11, but it's small enough that you probably will eventually say, oh yeah, I think it's prime.
Mm-hmm. And these last two, I might want a little bit of help for 13 and 14.
We should do 8 next. Sorry, I didn't realize your instructor was going down vertically, and then so we should do 8 next. I'm sorry for doing them out of order. 8's a good one to do because it may not be obvious what goes in there. But yeah, we'll go down to the next ones as well. So 249, 2 does not work because it's not even. So you try 3, 2 plus 4 plus 9, which is 15. So this one is divisible by 3 because it's a multiple of 15 is a multiple of 3. And that's where, again, you may have to come off to the side and do your long division.
Yeah.
I'm helping out here because obviously we want to move through this a little bit than the long division, but that's what you would have to do is come off to the side and do that. Now, do you have in your notebook all the prime numbers up to 80 something? Because that may have been why your instructor gave you this one.
Maybe I don't know.
But do you have in your
Not yet. She said
okay?
she'd
Let
look
me
it up as soon as the printer would work, but it wasn't working.
okay. Let me see if I can find one that's easy. I'll just drop them in the chat for now. That'll be pretty quick. So there in the chat, I've just shown you the list of prime numbers. Also, I think I can paste them in here reasonably well. So here's a list, and you can see
Yeah.
that 83 is on that list.
Okay, so it's prime.
Yeah, now you got to be careful that you like it's like sometimes students see the number 51 and they think, oh, that's prime, but it actually is not. So you don't it just because it kind of doesn't feel right. You've still got to work the algorithm.
Okay.
Okay. Now you mentioned doing the last two. Which ones were you referring to? Which numbers?
14 and 13.
Okay. Yeah. Let's do. Why don't you do 12,
Well, okay.
and then we'll move to those next two.
Hmm. Mm. Hmm.
What number goes into 201, or is it prime?
Prime.
So what's the next prime number to try after 2?
3.
It's 3. So you have to add the digits. What do the digits add up to?
3. So it would work.
So 3 does work. Now it's maybe not obvious now what it is, but it is a number. Okay, and I'm just helping out here for time purposes. Now 6 plus 7 is 13. That is not divisible by 3. But if you go
No.
back to your list of primes, you may find that 67 is a prime number,
Mm.
and it is.
Hmm.
Okay, we can move to 13 whenever you're ready.
Okay, I'm ready.
All right, so let me get this snipped in. All right, now whenever you're multiplying, you want to go vertical. So we'll have 36.8 and then 23.5. And you do want them to line up. So you want this right side to be lined up for sure. So even if they have different decimal lengths, you still line them up. Okay.
Yeah.
Now you do, if you recall, you actually count the number of decimal places. You can do that now or
1,
wait
2.
until the end. There's 2 total. Yeah. Okay. We're gonna use that later on. But now it's just a multiplication exercise. 5 times 8, 40, carry of 4. 5 times 6, 30, plus the 4 is 34. The 3 carry. 5 times 3 is 15, plus the 8 is 18. For each, every time you move over 1 digit, you have to pad it with a 0. You can cross out the carries if they're bothersome, but you start again. 3 times 8 is 24. That's 4 with a carry of 2. 3 times 6 is 18. Carry of 2 is 20. 0 with a carry of 2. 3 times 3 is 9. Plus 2 is 11. And then you pad with 2 zeros this time when you go to the number 2. And you can cross out your carries. They're not distracting you. 2 times 8 is 16. So that's 6 with a carry of 1. 2 times 6 is 12, plus the 1 is 13. 3 with a carry of 1. 2 times 3 is 6, plus the 1 is 7. And then you add vertically. And again, you may have some carries there. 8. All right, now this is where you have to use those decimal places that you counted. You move left the number of decimal places. So you're going to go left 2 times. That's once.
So,
That's twice. So
so
your final answer is 8. Go ahead.
864.80 or 0.8.
Yeah, 0.8. Yeah. Now I don't see the word check. You don't usually check multiplication, but you could. Do you know if that's expected here?
It's not.
Thank goodness. All right, well, let me know when you get all this down if you have any questions. I know I'm going quickly, but
Yeah.
this is a review for you. You do know how to do this.
All right.
Okay, let's look at number 14 next. All right, so with division, you have to figure out which number goes outside the house, which number goes inside the house. Do you remember which number goes inside versus outside?
It would be the 15 would go outside and the 69 would go inside. Because the one friend will always go inside the house and the one back always go.
Very good. Okay, now on the outside, you should never have a decimal as a preference. So you're going to move that decimal to the right one, which means you're also going to move the decimal in here to the right one. So your new problem, and if you want to erase, you can. I'm going to write a new problem here. It's 154 into 690.8. The decimal is so critical because that tells you the decimal, where the decimal goes in your answer. Let me know if you're up to this point with your notes, and then we can.
I am.
Okay, so we got to figure out how many times does 154 go into 6, and it's 0 times. How many times 154 go into 69? That's 0 times. How many times does 154 now go into 690? And that's where you got to come off to the side, and you got to kind of guess to make make a reasonable guess here. So you come off to the side, and this is the time consuming part of it. It's like, you got to figure this out. So this ends up being 616. Okay, and just to save some time here, I'm gonna give these numbers to you. So we know it's at least 4. But what about 5? So when you do 154 times 5, you get 770. So we know that 4 goes here because it's just a little bit less. 4 times 154 is 616. And then you subtract here. So when you subtract, you kind of got a problem here because there's a lot of issues here. You can bring the 8 down. The 0 is smaller than the 6, so you got to borrow from the 9. That's 4, and then 8 minus 1 is 7. 748, like that. So now you restart. You ask yourself, how many times does 154 go into 748?
And
I'm sorry?
It'll go on 4 times again.
4 times. Yes. Yeah. Perfect. So that's 616, and then we subtract, and then you can bring down the 0 when we're done. So it's 0, 2, 3, 1, 1,320. Okay, so 154 times 8, we get 1232, and 154 times 9 gives you 154 more than that, which is 1386. So you can see now that it goes in 8 times. I don't know how far you're supposed to go out. In the past, you said, hey, yeah, okay, so we can stop there if you don't have to round. But I mean, you can see it gets pretty bad pretty quickly.
Yeah.
So you're 2, 20, 19. Yeah, anyway, I think you could just stop there. So I want to extend our lesson a little bit, especially if you want to. We can go back and finish any of the previous problems that you've not done. So which ones have we not done yet? Looks like maybe 11 and 9. Okay, let's do 9.
Okay.
9. So 9 is 284. You're going to start with 2. Two again works.
So I don't know if I remember 71.
Yeah, 71 prime, or does something else go into it?
Well, 3 doesn't go into it because 7 plus 1 is 8.
Right. And so 5, it's not divisible by 5 because it doesn't end in 0, 5. So 7 is the next prime number to try. And this is where you either need to know the divisibility rules, which they don't help you much with small numbers like this. This one is not divisible by 7. So then you go to 11. Your multiplication table, though, does help you.
Not by 11. So.
And then 13 is, well, do you know your 13 multiplications?
Not that well.
Yeah, so you got to be careful here. Like if I'm your teacher, I might give you one that like works with 13 just to see if you're paying attention, but it does not. How about 17? So the only way to work around this is, do you have that list of prime numbers in front of you? Do you, and or can you look in the chat and tell me if 71 is prime?
Yep, it's prime.
It is prime. Now I'm not suggesting you memorize those, but you start getting a feel for ones that
Okay.
are kind of
And then
reasonable.
11.
Yep, let's do 11 real quick here. 840. 11 is
420.
840. Yep, 420. And then we do a 2 again, 210. 2 again, 105. That's where you want to, you try 3.
Which would work.
It does work, yeah. So 3 goes in. But 3 does not work with 35. And then you say, oh yeah, 5 does work 7 times, 7 is prime. And then you've got it.
Mhm. Okay.
Right. Let me do something real quick here. Stop recording.